Today we're going to be hearing from 3 individuals about the CUAHSI Summer Institute that is going to take place later this next summer at the National Water Center in Alabama. I know many of you people are still just logging in right now, so we're going to start and just wait a few more seconds to start. As a reminder, during the presentation itself, all attendees are going to be kept in muted mode, but if at any point you need to make note of a question, to ask a question of the presenters, please type your question out into the chat space, and then at the end of the formal presentation we will be able to turn our attention to those questions and we'll be able to answer them in turn then. Any questions that we aren't able to answer during the hour-long webinar we'll keep track of, and we'll be able to respond to attendees afterwards and share those responses with the whole group. So if you have any technical questions or other things, just type them out into your chat space, your question space, and I'll be monitoring that. And at this point, I'm going to turn the presentation over to Dr. David Maidment from the University of Texas. David, let me right now pass you the baton.
Okay, can you see my slides?
Yes.
Diane?
Yes, we can.
Okay, well, thank you so much. So thank you so much, Diane. I really appreciate this opportunity to talk with the UCGIS community and to have colleagues from UCGIS to join me. Joining me in this presentation is...
David, I'm going to jump in 1 second. If you could minimize your GoToWebinar, there you go, right up there. Then we'll be all set. Thank you.
Okay. Sorry about that. I'm pleased to be joined on this webinar today by Xiaowen Wang from the University of Illinois at Urbana-Champaign, the president of UCGIS, and also Mike Johnson from UC Santa Barbara. Mike's a grad student there in the GIS program working with Keith Clark, and he's going to be one of the 2 student coordinators for the 2017 Summer Institute, and he attended the 2016 Summer Institute as well as a participant, and so he's going to provide a student perspective on what the experience is like and what to expect. So the title that we have here is Collaborative Problem Solving at the National Water Center, and I thought to do this in 4 parts. First, to introduce briefly what's involved with the Summer Institute and CUAHSI and so on, then to talk a little bit about the National Water Model, then to turn over to Xiaowen to talk about CyberGIS, and then to Mike to talk about the Summer Institute experience. So firstly, a little bit of an introduction. This is the National Water Center. It's located in Tuscaloosa, Alabama, on the campus of the University of Alabama, and it was established there by the National Weather Service and by NOAA generally, and federal agency partners that include the U.S. Geological Survey, FEMA, and the U.S. Army Corps of Engineers. And it has a mission to assess hydrology in a new way at the continental scale for the United States, and that includes a national water prediction capability for the nation. CUAHSI is a consortium similar to UCGIS. It has 110 U.S. universities as members, and it's got a mission to be able to advance hydrologic science in the nation's universities in a collective way beyond what universities can do by themselves, and is supported by the National Science Foundation to do that. I've put a listing here of some of the things that are on the CUAHSI website, which is given here, https://www.cuahsi.org, and that includes members, the American Geophysical Union meeting, American Association for the Advancement of Science, and I noticed here also the American Association of Geographers annual meeting, so CUAHSI will be represented there. A specific deadline important to this program is on December the 18th, which is when the student applications deadline is for the National Water Center Innovators program, Summer Institute of 2017. In 2016, we had 34 graduate students from 21 universities whose symbols are given here, who gathered in Tuscaloosa. This is a completely open process where students from any university can apply and be selected, and it was just we had a wonderful time working together with the students and with faculty from who were selected as the mentors for the student projects, and I know it's an experience that everyone who participated in it will remember for a long time. Some of the things that we did during the Summer Institute, we started with a flood emergency response exercise with the City of Tuscaloosa and the County of Tuscaloosa. That's the person pictured here is Rob Robertson, who's the Emergency Management Coordinator for Tuscaloosa County. And we went through a flood that had happened in Tuscaloosa about 6 months earlier, and we went through the stages of the rise of the flood, the fall of the flood, and we dealt with the fire, police, first response community, and the Public Works Department and NGO, the Red Cross and so on, and learned about what they do at just different stages of a flood to build, to help citizens to deal with the problems that are involved. We also did field work on the Cahaba River, so it was kind of fun getting out there on the water. I think that's actually Mike in the far end of the boat there, and Jim Cole at this near end, who's the other student coordinator who's going to be involved in the Summer Institute in 2017. And so this is not just about being in classrooms and that. We also have some fun doing things outside. All the research projects that were undertaken in the 2016 Summer Institute were summarized in this report, which has been published by CUAHSI, and we're now having a special issue of the Journal of the American Water Resources Association to bring some of the papers forward for publication. So there's an annual cycle of activities that goes on. The part of it that we're in the phase of now is the selection of candidates for the Summer Institute. Then we have the Institute itself, which is going to be between June 12th and July 26th of this year. There's a boot camp, which takes a couple of weeks where we have an instructional program, and then everyone forms groups and figures out what research project they're going to work on. There's a research phase which lasts a month, 4 weeks, where the work is actually done, and then there's a capstone event which summarizes the results, and that's going to take place during the week of July 24th, and it's going to be followed by a CUAHSI Hydroinformatics conference, which will also be held in Tuscaloosa. Then there's a publications phase. In this case, there's the featured collection in the Journal of the American Water Resources Association. And then we go to a preparations phase, generally with a large-scale experiment to prepare data for the next Summer Institute. In this case, we're working on a large-scale experiment concerned with flood inundation mapping with the collaboration of the CyberGIS team. So we'll hear more about that in a minute. So if you're interested in participating, please see this website, which is https://www.cuahsi.org/Summer Institute. That has all of the information that you need. There's a special form that has to be filled out. You need also a reference from your advisor. The deadline is December the 18th, and there's quite a lot of information there. That what's provided for you is expenses for your travel and accommodation in Tuscaloosa. There is no stipend associated with this. You have to spend all 7 weeks in residence in Alabama. There's not, we don't have a program that supports being there only part of the time. And the person at CUAHSI who administers this program is Emily Clark, and she is on the phone and will be available to answer questions at the end of the webinar. So let me talk a little bit now about the National Water Model. This is an animation of the results from the National Water Model. It was this is in 3-hour time steps, and it covers a 3-month period last year when the model was being spun up in the in-car facility in Wyoming, and it shows the flow being calculated in 2.7 million stream reaches covering the continental United States. That's 5.2 million kilometers of rivers, or 3.2 million miles of rivers. And so the National Water Model takes weather information and translates it through the soil-water balance on the land surface into the river system, and it does a calculation simultaneously across the whole country for the flow in all the rivers and streams that you see here. This is the 1 to 100,000 scale NSD plus coverage that you see. And this process is going on now all the time. So the geospatial database that's used to support the National Water Model is the NHD Plus version 2.1, and this has been defined as the geospatial hydrologic framework for the United States. This in turn depends upon the National Elevation Dataset, National Hydrography Dataset, Land Cover Dataset, and Watershed Boundary Dataset. Each of those took about 10 years to develop between 1995 and roughly 2005, and then it took 10 more years to integrate them so that you've got a set of 2.7 million reach catchments in the United States of average area 3 square kilometers and average reach length 2 kilometers. And each little catchment has a unique ID which is associated also with the stream reach contained in it, and that's the way that the land system and the water system of the nation are connected. So the current forecast model has 4 different modes. The first, there's an analysis mode, which is the best estimate of current conditions, in other words the past coming up to the present. Then there's a short range forecast for 15 hours ahead in 15 hourly time steps. Then there's a medium range forecast, which is 3-hour time steps for 10 days ahead. And there's a long range forecast, which is for 30 days ahead, and it has 4 ensembles, each 6 hours, or 16 in all. And the graphic that you see up there shows pictures of the forecast, which you can query from the National Weather Service website, and you can find forecast information for any of the 2.7 million stream reaches in the country. And this is 5 terabytes of forecast information a day. Not only forecast as flow, there's also soil moisture and other hydrologic quantities as well. And this is a completely unprecedented accomplishment for the nation to be able to forecast water just like as if it was weather. Now, one of the things after the first Summer Institute that we had in 2015 that was really a point that impressed itself on my mind was the traditional way that we've done this kind of hydrology is, as you see at the top here, with river basins and basin outlets. These 2 basins that you see here are for the Blanco River at Wimberley, which is near Austin. And on average, there's these basins are 400 square miles in area, and in total there are 6,600 of them and 3,600 official forecast points in the current National Weather Service river forecast system, which is actually done in 12 separate centers in the continental United States and 1 in Alaska. In the new system, there's just one big network for the whole nation. And so the Blanco River at Wimberley is covered by 130 little catchments and flow lines, and there's just one great big network from the atmosphere to the ocean and from coast to coast. And this is an unprecedented development. We've never done this in hydrology before. And so traditionally we've worked with watershed hydrology with basins and outlet points, but what's happening now is an experiment in continental hydrology with a network flow continuum across the whole continental United States. Now, once we've got the forecast discharge, the question is how to map the flood inundation. And there are a number of ways of going about that, and one of them involves a calculation called the height above nearest drainage, which occurs, which is just a terrain analysis that says flooding occurs when the water depth is greater than the height above nearest drainage. So the height above nearest drainage of a house is the distance vertically between the elevation of the base of the house and the bottom of the stream nearby. And if the water depth in the stream is less than that, then there's no flooding, and if the water depth is greater, then there is flooding. And we did last year a terrain analysis across the whole nation with the help of the Roger supercomputer facility at the University of Illinois at Urbana-Champaign. We took the blue line set, the NHD plus flow lines, and the National Elevation Data Set, and we combined them together to give this height above nearest drainage raster for the continental United States. And that was really an amazing accomplishment that we pulled that off. What we're doing this year as our experiment is taking the same analysis and calculating the geometrical properties of all the stream channel segments for the whole nation in the same way that you see here for just the inundation map itself. And here's an example of how we use that. So this is Tuscaloosa County in Alabama, and the wiggly blue line that you see there is the Black Warrior River, and here's water starting to rise during a flood, getting to the main flood level, and then starting to recede, and then returning to normal again. And this is produced using the height above nearest drainage method that I just described. And I looked at all these maps and I thought, is that real? It seems like there's lots of blue there. But then we laid over that the address points that are used for dispatching of vehicles for emergency response. There's about 80,000 of those in Tuscaloosa County. And it's one of those really nice times in GIS where you suddenly go, oh, I get it. You know, there's no red dots in that blue area because people just do not want to live in that flooded place. And the emergency response people asked us at the exercise that I described, what's happening in Moundville? So here's this little piece of this, the southern part of Tuscaloosa County, and you can see that there's flooded properties there and a flooded road to get to them. And they looked at that and they said, oh, yeah, okay, that looks right. That's what happens. And it was just amazing to me that here we are in just this randomly chosen county in Alabama in some obscure corner of it, and an analysis done in a CyberGIS facility at the continental scale was able to correctly identify where the areas of risk are and depict them in a way that the local response community found authentic. And there's times that science just works beautifully, and this is one of those times. And I was really impressed that the CyberGIS facility was able to support us in this way. So to tell us more about that, I'm going to invite Xiaowen Wang to join us. And in doing that, what I want to point out is that what's happening here is a collaboration between the academic community and the federal government, with the partners, in this case CUAHSI and UCGIS, working with supercomputing and GIS. The R2O means research to operations, and O2R means operations to research. The National Water Centre is where the facility, the administrative facility is, but the calculation for the National Water Model is actually done in the Weather and Climate Operational Supercomputer System called WCOS, which is located in Maryland. And that's where the nation's weather forecasting is done. So actually, in the corner of the facility that is used to forecast the nation's weather is now being used to forecast the nation's water. And a point that's really come home to me as we've worked on the National Water Model is that we need a comprehensive geospatial information framework coupled with supercomputing to make this work. There's simply no other way to be able to do a hydrologic model at this continental scale without that. So with that, let me turn over to Xiaowen Wang to talk about the UCGIS and the CyberGIS Center.
Thanks so much, David. Can you all hear me?
Yep, very good.
David, can you hear me? Good.
Yes, very good.
Right. Yeah, go to the next slide. Yeah, so thanks to you all for joining. For those of you who might not be familiar with the UCGIS, this is the URL you could go to check out more information about UCGIS. Next slide, please. So we are an organization, 59 currently regular and affiliated members. You've heard earlier from Diana Seaton, who's our executive director, leads the day-to-day activities and operations. I'm Xiaowen Wang, the current president, and we have Elizabeth from ASU, past president, and Shashi Shakar from Minnesota, president-elect. So we are representing the broad GIS science and geospatial communities and have active partnerships with a number of related organizations, and also including the one CUAHSI, as Dr. David Mayman was presenting. Next slide. So a few examples about UCGIS, body of knowledge you might be familiar with, as well as research agenda. We are renewing the development of a new research agenda, as well as a number of community outreach activities and workshops, specialist meetings, which I'll mention a few more examples toward the end of my talk. CyberGIS, as David was describing, it's still a relatively young interdisciplinary field intersecting advanced cyber infrastructure, e-science, geographic information science and systems, and a number of geospatial domains. In this talk, I'll primarily be focusing on the technical capabilities because that's where got highlighted by the presentation you've just heard from David. But right now, CyberGIS is growing, is an active interdisciplinary field. Next slide. So the CyberGIS Center for Advanced Digital and Spatial Studies participated in the last year's Summer Institute organized by CUAHSI. And the mission of the CyberGIS Center at the University of Illinois is to empower advanced digital and spatial studies through innovation of CyberGIS technologies and applications. We have 5 key application domains listed on this slide. As you could tell, the hydro water resources communities work is here well represented, for example, through disaster and emergency, the flood examples brought up by David, as well as energy and water resources. The whole idea of what we are pursuing at the CyberGIS Center is to tackle big data problems through big compute approaches, facilitating, fostering large collaboration for solving big problems, such as the very societally relevant and important problems shared by David. The opportunity we see is really through the guidance of critical spatial thinking. This could go down to the advanced digital technologies, including 4 major components. CyberGIS is one of them, but also advanced cyber infrastructure, driven by computing and data-intensive application sciences, and this translates to the advances of geospatial sciences and technologies. So we see this loop getting pushed by advanced digital technologies and pulled by a number of opportunities of discovery and innovation, and that's what the CyberGIS Center is pursuing. Next slide. So you heard of this, and Dr. David Maidman was at the CyberGIS Community All Hands Meeting 2015 at USGS. He was sharing about this very exciting national project exercise, and that, in short, it's a NEFI, and what he was telling us was this powerful vision of continental hydrology enabled by the synergistic development of GIS and big data and high-performance computing. Collectively, we, of course, refer to as CyberGIS, and our preliminary progress on this collaboration has led to very exciting results, as you heard from David. And my short presentation here is hoping to demystify to some degree what happened at the CyberGIS level that has enabled the results we've been learning here. Next slide. So David mentioned some really important data sets, geospatial data sets at the national level. This is the one related to the topography representation and also hydrography data sets derived from the topographic representation. It's called a 3DAP. It's a 3-dimensional elevation program coming out of the National Elevation Data Set. Prior to this one, the exciting aspect of this is getting the representation of terrain and landscape and terrestrial scope into sub-meter, square meter representation horizontally and into below 10 centimeter vertically. And what this means is we're able to capture very detailed landscape and terrain features in an unprecedented fashion. And of course, related to this is the water features that we're leveraging for the prediction capability David was describing. Next slide, please. So this is one of the national exercises David was describing. It's the hand raster. And to me, from GI science point of view, I see this as the first ever attempt to characterize topographic influence or topographic features in the context of flood potential. This is just truly remarkable because you look at this from continental level, but at the same time you look at this at a very local, detailed level, such as the Alabama example we saw from David's presentation. This is very, very exciting because finally you got this huge data sets, big data. We are working with both data analytics as well as the representation, the visualization here. But the first time we are able to incorporate this topographic detailed representation into the estimation of flood potential, to me, I think it's a quite a breakthrough from the GIS point of view. Next slide. And this is really the computational process behind the map you saw, and the gist of which is you have detailed topographic features. You're going to condition those features. You're going to work on the hydro, water, resource aspects of those features at a very detailed level, and you're processing the features and linking to the elevation representation, which in turn leading us to the flood inundation mapping. And I'm listing a publication here led by my colleague Yan, and you could go to that URL to read details of this process. But another point I want to emphasize here is in multiple of these boxes, for instance, the flow calculations, this green color boxes, a lot of which they are extremely computationally intensive if you're looking at large scale, such as the continental scale, but also very detailed resolutions. And this is not anything you would be able to even conceptually achieving using conventional GIS tools and approaches. But because of the high-end computing environments and the big data capabilities we are evolving in the CyberGIS field, we're able to pull together this workflow, really achieve that inundation mapping you heard from me and David. Next slide. So the software environment between the advanced cyber infrastructure resources and the computational capabilities and the geospatial applications leading to discovery and innovation is this middle tier. You saw three components. CyberGIS Gateway, if you see the flood inundation map that's presented online, where you have a number of users could interact with that map, because ultimately such maps are going to be important to emergency responders, and such information needs to be visualized and presented in a friendly way so that both the public as well as the emergency responders could take advantage of the information. So we need to have very computationally powerful and sophisticated CyberGIS analytics, extremely accessible and friendly to large population of users who would benefit from such analytics. So that's what the CyberGIS Gateway is representing as a key software modality. The GISolve middleware serves the purpose of linking diverse cyber infrastructure resources and enable the applications to take advantage of such resources without knowing the nitty-gritty details of the complex cyber infrastructure environment. The CyberGIS Toolkit is the basic algorithmic building blocks of CyberGIS. In many cases, such building blocks are scalable to take advantage of the high-performance, parallel, and distributed computing environments we typically do not see from traditional GIS computational environments. Next slide. So as an example, I mentioned, for instance, several cases of using digital terrain as the basis for CyberGIS analytics. One of the very valuable tool in this context is the TALDIM, originally developed by Dr. David Tarbolton from Utah State University. We're collaborating with David Tarbolton's group on enabling TALDIM to be able to interact with CyberGIS analytics. This way, we would be able to resolve big data challenges and take advantage of big compute capabilities. And the flow delineation algorithms, for instance, as I mentioned in CyberGIS workflow, is directly out of TALDIM transformed into high-performance cyber infrastructure resources. But the gateway here is really a friendly environment. You would allow a number of users who do not have CyberGIS in-depth technical expertise to directly benefit from such analytics. For instance, the hydro community has been benefiting from the CyberGIS Gateway environment without having to learn the nitty-gritty aspects of the CyberGIS workflow. And underlying the software is a collection of advanced cyber infrastructure resources, and Roger, as David mentioned, is one very representative example. The whole point of Roger is we're coming to this age. We have tons of geospatial data, geospatial big data. We are representing some very unique requirements for advanced computing. One particular requirement is a lot of our scientific processes and analysis are very interactive. When we work on map-based scientific discovery, we expect this interactivity. It's very different from traditional high-performance computing-based approaches. You submit some very large computation jobs, and you could wait a few days to get the results back. That's not typically the case in the geospatial communities. And of course, a lot of our science cases are data-driven, including, for instance, the one we are learning today, the continental hydrology. It's very much based on, high-resolution terrain data, hydrography data sets, land use data sets. All of these data sets have important roles to play for the kind of predictions we're making. And this is, again, not very typical in a lot of simulation and model-based sciences. And we're also very much engaged in visual analytics, which means in a lot of traditional computational science domains, visualization is a post-processing step. But in our case, it's right in the middle, a critical step of our scientific processes. And if you combine all these requirements, our argument to the general science communities is the existing supercomputers and high-performance cyber infrastructure resources cannot adequately support the kind of scientific requirements posed by the CyberGIS and also the hydro communities, the examples we learned today. So what we proposed to NSF a couple of years ago, this system called Roger, is to combine the big data and the analytics capability with the traditional high-performance computing and the simulation capability with the cloud and the services capability to form this CyberGIS supercomputer that is able to enable the kind of science, the very exciting vision David shared for pursuing this continental hydrology, and otherwise would not be possible. Next slide. So Roger, in terms of the capabilities, we have about 6 petabytes raw storage and also solid state drive, enabling fast data access, and has graphics processing units. This is a GPU for exploiting geospatial data parallelism, and interactive visualization supported by the cloud computing component. And all of these 4 pieces are tightly integrated through the CyberGIS software framework I presented, but also at the hardware level through common data management tools as well as fast networks communication technology. And this Roger system is operated by the National Center for Supercomputing Applications, where the CyberGIS Center is hosted. So what Roger represents is this extreme scale geospatial computing data and communication system center. This is a very holistic environment, and to the GI science community, this environment is not that old. It's only, in fact, from the research point of view, took place in the past 4 years also. So it's very exciting, but at the same time, certainly posing education and workforce challenges. Next slide. So at the CyberGIS Center, similarly as we did through the partnership with the Summer Institute last year, CUAHSI was facilitating. We are conducting a number of workshops at UIUC, and you could tell these are the kind of topics typically you don't get to learn from your GIS courses or any other courses at all. But we've taking the initial efforts on formalizing the learning scope of these topics that are very much related to what I was telling you about the extreme scale geospatial computing, big data analytics, and also communication environments that would allow us to tackle the big problems such as the continental scale flood potential estimation and also continental hydrology. In fact, I see that is a very exciting new era for a new potential field. Next slide. So at the national level, the CyberGIS Center is working with the GIS science community through NSF support to organize 13 campuses and 17 fellows. The idea is as these CyberGIS fellows are practicing their teaching for CyberGIS related topics, we will organize the teaching materials together, and we have assembled the teaching materials developed by these fellows together into a central repository, and we have done some peer review process to vet the quality of the materials. Now we're in the process to figure out how to disseminate the teaching materials for CyberGIS across more broader communities such as the hydro communities. Next one. So to wrap up here is similar to CUAHSI, as David mentioned. UCGIS, of course, is a community representing the GIS science and the geospatial fields. We also have annual symposium. The next one is in May 2017, 23rd to 25th in Arlington, Virginia. The theme of the next symposium is CyberGIS and diverse partnerships for geospatial workforce development, which is very much tied to the kind of challenges I was sharing with you. Is the research now is very exciting. Now we need to make sure the workforce is catching up and even moving ahead in order to enable multiple related fields to capitalize on the research opportunities as well as educating the next generation for them to be able to develop new sciences and make advances accordingly. And prior to the symposium, again, this is similar to the Summer Institute concept of the CUAHSI organization. We will run a summer school at the CyberGIS Center and the National Center for Supercomputing Applications here at Illinois. It's a week-long summer school. We will work with the GIS science community and the other related geospatial communities to pull this summer school off, and we will invite primarily graduate students and junior scholars to come to interact with the senior scholars as mentors and work on hands-on projects. And one of the targets of our hands-on projects will be the experience gained through the Summer Institute of CUAHSI, particularly this, large-scale continental hydrology examples related to flood forecasting. So we're very motivated to bridge across different geospatial communities together in the context of CyberGIS, big data, and high-performance computing for solving important problems that are relevant to our societal issues. So for the summer school, the UCGIS is going to be organizing. If you have any questions, certainly I'm here to answer, but also Diana Sinton will be available to answer as well. Along the timeline of next month, we will be releasing calls for participation, and after New Year, we will be also organizing a webinar to spell out the participation details, and so it should be very exciting, because what I see is this grand opportunity we're facing in terms of revolutionizing discovery and innovation In fact, across many fields, and the continental hydrology story you learned today is a perfect one. But such opportunities enabled through synergistically advancing CyberGIS and geospatial-inspired computing and data sciences. Next one. So as you could tell, the magnitude of such opportunities does get enabled by the kind of support we've received across agencies and also partnership with the industry. I'm very grateful for such generous support, especially over a long period of time. And this concludes my part of the presentation. And please hold on until the end for any questions or comments you might have. Thanks.
Okay, thank you so much, Xiaowen. So now let's turn to the student side of it, and I'd like to ask Mike Johnson to talk about the student experience at the Summer Institute.
Hi everybody, my name's Mike Johnson. And like David mentioned at the beginning, I'm a grad student at UC Santa Barbara working with Dr. Keith Clark. So last year was my first year as a grad student, and so when I applied for this program in the fall, I was very new and still am to these ideas of what these models are and what the outputs are and how and what kind of inputs are needed into them. But the big thing about the Summer Institute is it's a great opportunity for grad students at almost any level in a lot of different disciplines to come together to kind of work towards accomplishing these large objectives that you've heard about today. So when I first came to the Summer Institute last year, it occurred to me that there were really three different venues or sides or communities that play into these models. There's the suppliers, which really give the data and the models, and those are the local agencies, researchers, national labs. There's the operators that are like the National Water Center and the National Water Model, and then there's the users, which are citizens and decision makers and the first responders. And not only do you get to kind of in the classroom setting at the beginning of the boot camp get to meet these people, but you also get to introduce to the processes and the faces behind them, which really helps make it more personable and easy to understand what the goals are and what is being done to accomplish those goals. So right now it seems that the suppliers, the data and the models, and the operators at the National Water Center are coming together very well to create this discharge models that Dr. Mayman showed at the beginning. But one thing that the group that I worked with really kind of noticed was that there is a somewhat of a disconnect right now between taking these outputs that are still relatively new and really state-of-the-art and delivering them to the users in ways that they can understand and use them. And that's where being under Dr. Clark at UCSB really see the ability for photography and visualization and some of these other ideas in GIS, apart from the developments and computing side of it, to really play into this year's Summer Institute. If you could do the next slide, please. Can you get to the next slide, Dr. Mayman? Cool, perfect. So I think generally at a very fundamental level, GIS can help catalog, manipulate, process, and then visualize and share data. And this ability to share and visualize data was the way that our project kind of focused last year with this idea of the disaster zoo, which can be seen here, which kind of acted as a centralized platform for sharing these flood forecasts and this national water model outputs through an online GIS that was accessible through a hyperlink. The idea behind this was to improve alert systems that are generally very broad and county-based and centralize them to something that is applicable and directly relevant to the people looking at them. And so what this is aiming to do is be able to take these data layers that are provided by the different suppliers, so you have the open shelters that people can go to, the output of the flood models, the flood discharge, and also the local transportation networks and such, and how do they all interact and integrate in order to help people meet them really where they are, giving them the information that they need. So the cool thing about Summer Institute is that projects can range across any number of spectrums. There's people from computer science, from hydrology programs, from atmospheric science programs, and they were able to come together and bring their unique skill set to address problems that were interesting to them, but also tied into this larger goal of helping people and really predicting better flood or generating better flood forecasts and information. So if you could go to the next slide. If you could get to the next, perfect, thank you. So the other thing I really would like to highlight too is that this isn't just you go and you sit in this National Water Center, which is a world-class facility, and work like you do maybe throughout the year in the graduate program, but you're getting first-hand experience with some of the really high-quality equipment. We used LiDAR station, survey equipment. We got to use a fish sonar to take measurements of stream beds. But you also get to experience a lot of what the area around Tuscaloosa has to offer, and you get to meet a lot of really great peers that will become lifelong friends and that you'll carry on relationships through with till today. I'm still in contact with a number of people from the Summer Institute, and it's the experiences both within the academic sector but also outside of it that really help you get into this community, understand what their goals are, and then start contributing in ways that are interesting to you. And what I find interesting about that is that it is a way to really bring out the best in everybody's work, the best in their intentions, the best in their motivations, and it helps tie what, at least to me as a grad student, felt like this very minute body of work tucked away in California, and it helps see how it's going to tie in and integrate with something that's much larger and really will impact and help people across the country. And then, so yeah, with the last slide, I think this map, when it pops up, the map here, this is the places that we were able to visit through the summer. And I mean, we had 15 people going at a time to visit these places and just explore and see what these areas were like on the weekend. And as much as it is about these academic opportunities and getting the published articles at the end of it and creating the technical report and having really solid research to show, it is about making friends in the community, getting to be kind of on first name or regular basis with these people at these federal institutions, top names in our field, like Dr. Maidman, meeting the faculty advisors of other students, and really having a network and a community that you can rely on, bounce ideas on, stay connected with, and work with through however long you care to take those relationships. So this year's themes are hyper-resolution simulation, cities, flood, inundation mapping, communicating National Water Center results. For me, being more on the visualization and cartography side of GIS, that last theme there is one that I really see potential for graduate students in GIS to come and contribute to. And I think that theme is being led by Dr. Nelson from BYU. And it's focused on making applications and really taking this awesome output that these suppliers and operators are generating and giving it to people and first responders and decision makers in a way that they can actively go out and really affect people's lives. And I think that's kind of what I've got. And I guess at this point we would open for questions.
Yeah, so thank you so much, Mark. I really appreciate your contribution and that of Xiaowen to this webinar. So this is just the same slide again that I presented partway through the seminar. One of the things that's really heartening to me is that it's really obvious that Geographic Information Science is making an important contribution to public safety at the national level in helping with flood information awareness. And the emphasis that Mike was placing on communication and Xiaowen was placing on the computation of the results are both key pieces of that. And it's really heartening to me as a hydrologist to have this interdisciplinary interaction with Geographic Information Science to help this to happen. So again, the deadline is on December the 18th, and for questions, and you can email Emily Clark at thatcomgir.CUAHSI.org, and we hope that some more students like Mike and others from the UCGIS community who joined with us in 2016 will be able to join with us in 2017. Thank you so much. So we're available now for questions.
Yeah, and for that, Dr. Maidman, I'd like to make one more quick point too. From the student perspective, this is all funded and paid for. You just have to contribute your time and your summer. But that is a big key that I know a lot of students had, and if you have the time, there is really not a better way to spend the summer.
Thanks,
Super.
Mark.
Super. This is Diana. I'm jumped back on here, and we've got a couple of questions that have come through. One person's wondering whether the program is limited to grad students, and do those grad students need to be U.S. citizens?
Emily, are you on the phone?
I am. Can you hear me?
Yes, we're here.
Okay. Hi everyone, I'm Emily Clark at CUAHSI. So the eligibility requirements are on the website as David pointed out, but we are accepting applications from current or incoming graduate students affiliated with U.S. universities. So you don't have to be a U.S. citizen, but you do need to be affiliated with a U.S. university. Yeah.
Super. And related to that, just in terms of student specifics, we've also been asked about what technical skills and background do students need to be successful at the Institute, perhaps what range or depth of GIS background and programming languages.
Mike, can you speak to that?
I would say, so the way that it kind of worked at the beginning was everybody comes in, we hear from the theme advisors about kind of where they might envision the theme going, but then you kind of form your own groups based on the students that are there and the strengths that those students have. So you get an idea of what the overall goal is, and then you can pair up with how your strengths best align with other students. And so I think if there's a skill that you can see applying well to one of the themes or an idea of how these things might carry forward, bringing that strength, and you'll be able to pick off the strengths of those other students you're with as well. So it's largely project dependent and who you're working with dependent is the best answer I have for that.
Yeah, and let me emphasize also, one of the intents here is to encourage innovation through rapid prototyping. And so we want to have the idea that there's student-led projects. We're defining what we think important themes are that need advancement, but we're not trying to tell you how to get that done. Like the flood hippo thing and the other visualizations that Mike showed in his presentation were developed by him and his team. We didn't determine any of that at all. We tried to help to support that with technical resources, but not to determine the direction that the groups went in specifically carrying out their goals. So besides just technically accomplishing things, one of the ideas here is to encourage young people to have confidence in their ability to lead, to have confidence in their knowledge and capacity. Now, America is a country that looks to young people for leadership, and this is one of the intents that we have here. These group-formed projects which take place in terms of the formulation over the first couple of weeks are a way for you to formulate your thinking and present what you think is important together with some peers that you get to know as this process goes along, and work together to produce a collective product that will represent what you can see would be a contribution. Now, having said that, this isn't really the place if you want to say, oh, I'm going to do my PhD research in Tuscaloosa for 7 weeks, and that's not what this is about. It's about joining with others in a group effort to create something new that you probably never would have done otherwise if you hadn't been at the Summer Institute. It's a good experience for those who, I would say, in the late master's or early PhD period, because you can see a whole national picture across the whole country and how a very large problem is being addressed and what the various components of it are. And that makes it easier to say, oh, if I did some research in this area, I could advance, it would fit in like this. So I think it's a good exposure for students at the sort of the outset of the PhD experience, if that's where you're at.
So
if I could add,
go ahead.
Oh, I was going to say one thing to add to that is also, yeah, these ideas that Dr. Mann is talking about that really aren't formulated when you get there, that's what this kind of experience, it's like a summer camp almost. People come together. The idea of Flood Hippo was kind of conceived at 3 a.m. one night when we were all just hanging out in a room. It's don't necessarily come with this is what I want to do, as Dr. Mann alluded to, but kind of here's some skills and here's the broad picture, and really rely on the conversations and these relationships that you build with people you've never met before to kind of guide that creation process.
Yeah, I wanted to comment on what David said, echo with what he said was this student-centered innovation. Along that line, we see tremendous opportunities for students to learn new capabilities, new research capabilities. One of the examples was, for instance, CyberGIS Jupyter Notebook. we experimented with this last summer institute CUAHSI pulled off, and I expect this will be even further developed. So the Jupyter Notebook, for those of you who are not familiar with it, allows students to work as a team to share algorithms, to share coding, to share visualization. So this is very much you're able to work as a team, but also very much student-centered. You could pursue some common ideas, and behind this CyberGIS Jupyter, you're able to access most advanced and powerful computational capabilities and resources, and some examples I mentioned and David mentioned. So what I want to say is the opportunity for getting exposed to research computational capabilities is very unique and powerful. And although some weeks you might not be able to carve out some PhD level questions or problems, but definitely you will learn something will positive benefit your graduate studies.
Thanks, all of you. Let me jump in here with another question that's been asked. So the students design their projects, but they are focused in general on certain themes of that particular summer institute. And what are the themes? Can you remind us the themes for the 2017 institute?
Yes, so our there we go. So the themes are hyper-resolution simulation, which deals with high performance, well, with numerical hydraulic calculations, and this is we're probably going to use the geisha model to talk about two-dimensional floodwater movement over land areas. And the idea is to be able to not just deal with flow in rivers, but deal with flow in streets or in or over land areas in the rural countryside where there's an intense storm happening. For example, that happened in Louisiana just a few months ago. The second has to do with this flood inundation mapping. So the National Weather Service calls the idea of inundation mapping, particularly real-time inundation mapping, the holy grail of being able to translate the result of a discharge forecast into an anticipated flood inundation map, which lies over an affected landscape. And the hand method is one approach to doing that. Some of the projects that we worked on last summer dealt with alternatives to that, and we're trying still to complete that process. It'll take several more cycles, I think, before we've got it perfected. And then Mike mentioned this, communicating the National Water Centre results. How do you communicate with citizens? How do you communicate with the first responders? And in a sense, as he mentioned, I think this is a particularly fruitful area for engagement from the student perspective, because there's this perception that the millennial generation have a better way of being able to communicate with devices and handheld things and so on than people who've been around a while like me. And some of the imagination that was demonstrated, like who would have thought of flood hippo? I mean, I never heard of flood hippo before. I mean, I can see the idea of being able to find something that's got a really memorable name. So these are the three basic themes that we want to follow, and the process that goes on is that during the first couple of weeks, you get to know and form a team, generally 3 to 4 people, and then formulate a project, and then I and other faculty mentors, Jim Nelson and Fred Ogden. Fred Ogden is leading from the University of Wyoming, is leading the hyper-simulation theme. I'm doing the one on mapping, and Jim Nelson is doing the one on communicating the National Water Centre results. Then we meet with the students and help to formulate the projects. Then the work goes on for a couple of weeks, and then we have a sort of mid-course review where we go through the whole thing again. I come to Alabama, and others as well. There's also Saga Cohen and Sarah Preskowitz from the University of Alabama who work with us on this as well. And we go through these things with each team and help to refine the vision and the direction of the work, and so that it's more likely to be productive. And then there's a couple more weeks of work, and then there's a paper that's prepared for the final report of the project, and oral presentation and so on. So that's sort of the process, and it's not like the teams have to sort of figure everything out on their own. They create the initiative, and then we provide reflection and guidance to help formulate the projects in the most fruitful manner.
Okay, that's really helpful in characterizing the types of things that might happen. We are at the top of the hour. There are a few questions that we weren't able to get to right now, but I'll make sure that the presenters, I share those with the presenters, and we'll write back to the full audience with those responses. And this recording, or rather this webinar, has also been recorded, and so we will provide you all with the link to the recording so that you can share this across your networks and see if we can let as many grad students as possible know about this great opportunity. So thank you all.
Feel free to email. Yeah, feel free to email us also, Diana. You know, Mike and Shelby and I are happy to answer questions.
Super. Yep. I will get to that. We will do that. All right. So thank you all very much again for your participation during this UCGIS webinar. This is the last one for our fall semester 2016, but we've got some very exciting ones currently being scheduled for the spring semester of 2017. These are all going to be announced shortly on our website. So stay tuned to ucgis.org, and thanks again everyone for being part of this exciting session today. We'll talk to you soon. Bye-bye.
Thanks, Diana.
Thanks, Diana.